we are going to be looking at angles and rotation. And if you don't know your special right triangles or like the ratios, like the SOHCAHTOA, make sure you have out your Objective 1 notes as well when we go over this. So one of the things that we're going to be looking at is like, how do we define an angle in a coordinate plane? And so in particular, what we're looking at is we're going to be talking about rotations of angles. And so we need to make sure that we have like all of the pieces and we understand what each of those mean. So we have an angle here. So we'll have what we call an initial side, which will always be fixed. So this will not move off of the x-axis. So it will always be there, right there. And then standard position is when we rotate in a clockwise direction, or a standard positive position is when we rotate in a clockwise direction. And when that rotation ends, we call that the terminal side. So we have an initial side that is fixed. And then the second piece of an angle will rotate off of the x-axis, the positive x-axis, and rotate in a counterclockwise direction for a positive rotation, and that will give us the terminal side. Okay, so we have the initial side and the terminal side. Initial side fixed on the x-axis, terminal side rotates and goes wherever the heck it wants to. When we go to measure an angle, so when we look at the measurement of an angle, we are talking about how much does it rotate from the initial side to the terminal side. So how much does it rotate from initial to terminal? And then when that rotation is going to be positive is when we go in a counterclockwise direction, and that measurement will be negative when the rotation is clockwise. Okay, so two pieces that we need to make sure we understand. So when we go up from the x-axis, that is a positive rotation. When we go down from the x-axis, that is a negative rotation. Okay, so clockwise downwards is a negative, counterclockwise upwards is a positive. And then the other definition that we need to make sure that we know is what we call a quadrantal. So a quadrantal is when the terminal ray is on either the x or the y-axis. So sometimes I refer to them as our corners. So this is a quadrantal because it's on the x-axis, another quadrantal because it's on the y, another quadrantal because it's on the negative x, and another quadrantal because it's on the negative y. Okay, so a quadrantal is basically our boundaries of our quadrants, and that's what a quadrantal is. Okay, so for question number 1, they're asking us to label the quadrantals in a positive rotation. So that means we have our initial ray, right? That is right here. And then when we rotate up to the first quadrantal, okay, that would be to rotate up to here. That's what we're referring to. So like how many degrees did I rotate? So our first quadrantal, so this would be right here, the positive x, that would be 0 degrees because we didn't go anywhere, right? We're just, whoop, there we are, 0 degrees. And then when we rotate up to the positive y, that is 90 degrees. So we just rotated 90 degrees. And then when we go and we continue that rotation, we go another 90 degrees. So that would put this at 180 degrees. And then we rotate to the next quadrantal. We moved another 90 degrees. That now puts us at 270. And then we rotate again, another 90 degrees, and that puts us at 360. So I put the 0 on top of the positive x and the 360 on the bottom because that tends to say, okay, I'm starting at the 0 going upwards and I end at the 360 at the bottom, okay? So 0 and 360 are in the same position in terms of like your initial and your terminal. It's just the amount of rotation is what is different. All right, so for question number 2, we're labeling the quadrantals, but this time we want to go in a negative direction. So that means we're going to go downwards, right? So we're headed downwards. So again, my initial ray will start here. And so I'm going to start at 0 going downward. So I'm going to put the 0 degrees this time below. And so then now I'm going to head towards the first quadrantal, so that y-axis. And so I just went 90 degrees, but because I went in a negative direction, I need to put a negative there. And so that just indicates direction. It doesn't mean that the angle is negative 90 degrees big. It's still 90 degrees. I just went in a negative direction, negative rotation. And so then now I'm going to keep going. So I'll go another 90 degrees, which will put me here, which is a total rotation of 180 in the negative direction. Then I'm going to go another 90 degrees, which is a total of 270 degrees, but in a negative direction. And then another 90 degrees for a total of 360 degrees rotation in the negative direction. All right, so that is that part. So now we have to do, we want to sketch each angle in standard position. So when we do that, standard position, remember we need to have our initial ray. So that will be right here. So there's our initial ray at 0. And I want to rotate 200 degrees. So I know every time I pass through a quadrant, I've gone 90 degrees, right? So when I am going to draw in my terminal ray, so I'm going 90 degrees, another 90 for 180, and then a little bit more, right? Because I don't want to make it all the way to 270, so a little bit more. So then that would be nice and straight. Pretend that's closer to this axis, but I guess scale doesn't really matter. We can say not to scale. So that would be 200 degrees. So another way to kind of look at that, just to make sure we kind of understand, that piece of things like what I'm talking about here is, I'm going to shrink this just a little bit, is that if I look here, I can see, I'm somewhere between, 180 and 270 will give me that 200 degrees. I'm closer to the 180, so I should have been up a little bit higher. Okay. All right, so let's go ahead and take a look at the next one. This one I'm going to, because they're both the negative, I'm going to leave it shrunk just a little bit so we can look at my quadrantal labeling up above. So this time I want to move a distance of 80 degrees, but I want to go in the negative direction. So when I draw in my initial ray, I'm going in a negative direction. So that means I'm going to be somewhere between 0 and 90. So I'm going to be in this quadrant here. So that's quadrant 4, but closer to the 90, right? Because negative 80 is pretty close to negative 90. So that would be somewhere over here. So I rotated 80 degrees in the negative direction. So I went that way. And then for this one here, negative 150. So 150 is somewhere between negative 90 and negative 180. So I'm over in this quadrant here. So again, we're starting at our initial ray, which is this one right here. And I'm going in a negative direction, so downwards, right? So I'm going to go downwards. And I'm not going to make it all the way to the 180. So we'll just say somewhere around there. And that would be how we sketch an angle in standard position. Okay, so this is an important definition. We're going to be using reference angles a lot, this particular unit. So make sure that if you have any points of confusion on reference angles that you ask the next day in class, right? So our reference angle, we use the symbol here, theta, with an apostrophe. And when we read that out loud, we say theta prime. So when we see that symbol, that circle with a line through it, that's the Greek letter theta, and the apostrophe, we don't say theta apostrophe, we say theta prime, so theta prime. And the definition is the shortest rotation to the x-axis of the terminal ray. So that probably should clarify the shortest rotation of your terminal ray. To get to the x-axis. So whatever you need to do to get to the x-axis. Okay. All right. So I'm going to go ahead, since we're talking about getting to the x-axis, so I'm going to call that 0 degrees. This will be 180 degrees. And then 360, of course. So whenever we are looking for the reference angle, we always want to make sure that we're paying attention. We want to get to the x-axis, right? We want to get to the x-axis. So this particular problem, we know that we have an angle rotation of 230, and they already drew that in for us. So there's 230 degrees there. So I want to be able to rotate this terminal ray up to the highlighted line, and I want to go the shortest distance. So I have to ask myself, okay, which way is shortest? Do I want to backtrack to get to the 180, or do I want to keep going forward to get to the 360? Well, this is the longer road, so we don't want to head there. So we want to figure out, okay, what is that distance between 180 and 230? And that will be my reference angle. So theta prime. So my rotated angle is 230 degrees. I'm trying to figure out what is my reference angle, meaning how far do I have to travel to get back to 180? And so to do that, I would just do 230 minus 180 degrees, which would be 50 degrees. So then my reference angle, theta prime, would be 50 degrees. And then before I forget, the reference angle is always positive regardless of direction. So we look at it as a distance, right? Because we want to know the shortest rotation. And so we look at it as a distance, which means we just want the positive value. So oftentimes when we're talking about distances or side lengths of a triangle, we always use positive values. Reference angles, always positive. Rotated angles can be negative, but reference angles have to be positive. Okay, so let's take a look at this rotated angle. So this rotated angle, theta, is 340 degrees. And then I am looking to head to the x-axis. And in order for me to get to the x-axis, I have to figure out, well, which way do I want to go? Do I want to get to that highlighted line by continuing forward, or do I want to backtrack and head over here to the 180, right? So which one do I want to head to? Which one is closer? And well, this is closer, right? So I don't want to go that way. So I need to see, well, how far apart is 340 from 360? So in order for me to figure out the distance between those two, I would subtract. So 360 minus 340 is 20 degrees. And so theta was 340, my rotated angle. And then my reference angle, which is the distance to the x-axis, is 20 degrees. All right, so for this one right here, so I have negative 225 degrees, so they drew that in there for me. So I know that this is negative 225, so that would be from 0. And so I want to look to see what is the shortest distance to the x-axis. And so when I look at this, so because I'm going to be doing reference angles, remember we just want the positive value, right? So just the shortest distance. So I know that this would be rotating from 0. So this would be at, I can think of this as negative 180, but because I'm going to be doing distance, I'm going to be thinking of these as absolute values. And so this is the shortest way to get there, right? Because if I went back this way, I'm like, oh, that's so much further, don't want to do that. So we're looking at this distance here. So if, again, because I'm finding distance, I'm going to look at that positive value. So I would do 225. And then how far away is it from 180? And so then I would subtract and get 45. So my rotated angle is negative 225, but my reference angle is 45 degrees. So reference angles, make sure you're always looking at the positive value because we're looking at distance. Okay. So let's take a look here. So for this question, they're just asking us for, practicing with all those things put together. So that's what we're going to be doing. And we'll just do a couple of these. I don't think we need to do a ton of them. So for question number 9, they want us to sketch each of the following angles in standard position. So we'll start with that. So I'm just going to go ahead and write my quadrantal values here. So if you don't know them yet, you're just adding 90 degrees each time, right? And I'm trying to graph the rotated angle of 260, which is somewhere between 180 and 270. And so I'm going to go ahead and, say it's closer to the 270. So just draw that here. And then my initial ray, of course, is here. And then I'm going to show the rotation in a positive direction. So there's part A. And then for part B, we want to identify the quadrant. So just as a reminder here, so your quadrants start up here where everything's positive. So that's quadrant 1. And then we rotate in a clockwise direction. Interesting. So that's the reason we do that. That's why the quadrants are numbered so wonky is because of that whole angle rotation we're doing right now. So quadrant 1, quadrant 2, quadrant 3, and 4. So if you don't remember those, make sure you have that labeling kind of learned as well. So in this case, we're down here in quadrant 3. So now for my reference angle, so that is the shortest distance to the x-axis. So I'm going to highlight this, and I need to figure out, okay, well, where do I need to go, which direction to get the shortest route? So, do I want to backtrack to the 180 or keep going forward to the 360? Well, the shortest route is this distance right here. So that's the distance I'm going to be looking for. So I'm just going to do 260 degrees and then subtract that from 180. So that would just be 80 degrees. And so then my reference angle, theta prime, would be 80 degrees. Okay. All right, so let's go ahead and let's do another one. So we're going to do number 12. Okay. All right, so again, we want to draw this in standard position. So the first thing I'm going to do, though, is I'm going to go ahead and label my quadrantals. So I'm going in a negative direction, so I'm going to put my 0 below, and then we're going to rotate downwards. So downwards meaning a negative direction, and that's 90 degrees. Keep going, right? Keep going around. So another 90 would be 180 in the negative direction. Another 90 would be negative 270. And then finally finish it up here at negative 360. So where does negative 330 land? Somewhere in this quadrant, right? So somewhere between 270 and 360. So maybe we'll call that right here. Get in my initial ray as well, and then put a rotation. So then that is in quadrant 1. So my reference angle, so I'm looking to see, like how far away I am, right, from the x-axis. So how far away am I from the x-axis? Well, first, which direction do I want to go to get to this highlighted line? Do I want to just drop down here, or do I want to go the long way? I definitely don't go the long way for the reference angle. So I'm looking to see, so this was, remember, 330 degrees, and I'm doing the positive value because I'm working with reference angles, right? So distances. And so I'm going to use the positive version here as well, so absolute value. So how far apart is 330 from 360? So I'm just going to subtract. And so then my reference angle would be 30 degrees. Okay? All right, so reference angle is super important, but if you're at all confused, be sure to ask. Okay, so you guys have seen these before, right? This was on our objective 1. So these are our special right triangles that we need to know really well. So we know for a 45, 45, 90, that means we have a isosceles right triangle. So that means these sides will always be the same, right? And then my unit triangle means my hypotenuse is 1. And then on my 30, 60, 90 triangle, I know that across from the 30 is 1/2, right? It's going to be half of that hypotenuse. And then across from the 60 is going to be √3 of that, or √3/2. Okay, so we need to know those particular triangles. And we're going to use these a lot, so make sure that you know these. And at some point, you're going to have to do a little bit of memorizing. So I'm going to keep that kind of shrunk so that I can reference that. So for question number 13, they want us to find the acute angle. So acute angle, just as a reminder, means an angle that is less than 90 degrees. So my answer should not be 145. It should be somewhere between 0 and 90, not 90 though, because 90 is a right angle. That would satisfy the following equations. So when we're looking for sine of theta equal to 1/2, so what I'm trying to do is, what I need to kind of focus on, let me get a different color here, is I am looking at, which triangle am I working with for starters, right? That will have any of these values, because we won't be using the hypotenuse per se. Okay, it could be, so which of these values here am I looking at, right? So that is kind of my focus. So I know that a 45, 45, 90 only has 1/√2 on it, or √2/2. And then, of course, it has the hypotenuse of 1. 30, 60, 90 triangle only has a 1/2 on it, a √3/2, or a 1. So for question number 13, they're asking for basically what triangle are you looking at? So if I have the sine of theta is equal to 1/2, what triangle am I looking at? What triangle has a 1/2 on it? And that would be this one right here, right? There's that 1/2. So then I know my answer has to be either 30 degrees or 60 degrees. Can't be 90, right? It's either 30 or 60 because I'm looking for an acute angle. So now I have to figure out, well, is it 30 or is it 60? So this comes into play with knowing what is the ratio for sine. So my sine ratio is opposite over hypotenuse. So the angle I pick, the 1/2 has to be opposite of it, right? So I'm going to do this wrong. So if I were thinking, oh, it's sine of 60 degrees. So here's 60 degrees. Opposite of 60 is √3/2. Hypotenuse is 1. Well, that certainly is not 1/2, right? So do you see what we're doing there? So, okay, 60 was wrong. So what about the 30? Let's try the 30 degrees. So if I did sine of 30 degrees, I do opposite, which is 1/2 over 1, which is 1/2. Okay, so then my answer is not 60 degrees, but 30 degrees. All right, so let's talk about that again, just to kind of make sure that we're on that right page, because again, you know, at some point we're going to have these memorized, but just to kind of be clear. So let me erase all of this here. So when I go to do this problem, it's asking for what angle will sine be equal to 1/2. And I know sine is opposite. Here is 1/2. So what is the angle opposite of 1/2? 60 is adjacent to it. So that would be 30 degrees. And so then I know the answer here is 30 degrees. Okay. All right, so let's go ahead and take a look at another one. Zoom here just a little bit. Okay, so I'm going to take a look at, being kind of stubborn. Trying to shrink that and still see it, but it will not let me move very well. Okay, so I'm going to do 15 before I do 14. So I'm going to do a couple of these. All right, so the first thing I need to do is figure out, okay, what triangle should I be working with? Okay, so that should be the first thing that I'm looking at. So when I look at this question here, so 15, it says cosine of theta is equal to 1 over the square root of 2. So if I look at the two triangles, I'm looking to see, okay, what triangle has a 1 over square root of 2? And that would be this one right here. So then I know that I'm looking at the 45, 45, 90 for the acute angle. So that means that theta is either going to be 45 degrees or 45 degrees. Well, that means we have no choice at all. It is just going to be 45 degrees because that is where cosine is equal to 1 over root 2. So what about 16? So same thing, okay? So we want to look at 16. So I will come back to 14, I promise. That one's just a little trickier. So this is asking you for what triangle will sine of theta equal root 2 over 2. So if I look over here, no root 2 over 2, no root 2 over 2. Aha, root 2 over 2 on both of these. So that means I'm looking at the 45, 45 triangle. So is theta equal to 45 degrees or 45, right? So I don't have a choice. It has to be 45. Okay, so let's take a look at question 14. So this is not in a fraction form, so I'm going to fix that. So I'm just going to put this over 1. So this one's a little trickier because if I look, I don't have a triangle that is root 3 over 1, right? Root 3 over 1. And that's because tangent is opposite over adjacent. So hypotenuse is a side that's equal to 1. So that means we're not dividing by 1, but we're dividing by something else. So if I look to see, okay, well, where does tangent theta equal the square root of 3 over 1? Well, it can't be off of this triangle because there's no square root of 3 at all. So it has to be off of this triangle. So I have a 50-50 shot, right? So theta is either 30 degrees or it is 60 degrees. And then my job is to figure out, okay, I need to get opposite over adjacent, and I need the root 3 on top. So here's the root 3 over 2, and I need the root 3 on top, and I know tangent is opposite. So which angle is opposite? 30 is adjacent, 60 is opposite. So I believe it's going to be 60 degrees, but I'm going to check it. So we're going to check, is the tangent of 60 degrees equal to root 3 over 1? So tangent of 60. So opposite of 60 is root 3 over 2. Adjacent to 60 is 1/2. I'm going to simplify by multiplying the common denominator, which is 2. So that will reduce and that will reduce. And then I'm left with root 3 over 1. And yes, that is what it is. So that means my answer is going to be 60 degrees. Okay, so let's go ahead and do these last two problems. So these last two. So for cosine of theta equaling to 1/2, so the first thing I want to do is look at the triangles above, right? So when I look at the triangles above, which of these has a side of 1/2? Well, they're kind of messy because I've been writing all over them. So which of these has a side of 1/2? And that's this one over here, right? So this one has a side of 1/2. So I know my answer is either going to be 30 degrees or 60. So that's pretty refreshing, right? 50-50. Yeah, I could totally live with those odds. So I know that it's got to be either 30 degrees or 60 degrees. And I'm looking for cosine, right? Looking for cosine. So if I look at that triangle, so let me just, I was going to draw it, but we could just go back up here. So cosine is going to be adjacent over hypotenuse. And I'm looking for it to be 1/2, right? 1/2 over 1 because the hypotenuse is 1. So which angle is adjacent to the 1/2? Which angle is adjacent to the 1/2? Well, here's the 1/2. Which angle is adjacent to it? The 60. So then my angle has to be 60 degrees. Okay, last one. Tangent theta is equal to 1. So we'll make that 1 over 1. So remember, tangent is opposite over adjacent. And then I have a 1-to-1 ratio here, right? The only way that opposite over adjacent is going to equal 1 is when the opposite side is the same as the adjacent side, right? So the opposite side has to be equal to the adjacent. Otherwise, there's no way it would reduce down to 1. So which triangle up above has the opposite and adjacent side equal to each other? Well, if I look over on this side, these are definitely not equal to each other, right? That's 1/2 and root 3 over 2. How about over here? 1 over root 2 is equal to 1 over root 2. So this is where the opposite side and adjacent are equal, so it has to be 45 degrees. So this part right here, we're just looking to get you to kind of be able to use your triangles to figure these out because you already know your special right triangles. But at some point, we're going to ask you to actually have these memorized. Okay, and that's it for right now.